This is our first present worth method example, and we're going to start off at the very beginning. So we have just a single choice. So one of the easier problems, we have just a single choice. So first of all, I want to talk about the points that I have made down here. So it's a present worth of one choice, just a single choice. And really, even when we're looking at a single choice, we do have an alternative, and the alternative here is do nothing. So if our present worth is negative, then we're going to want to do nothing here for this example. If our present worth is 0 or greater, I say or better here, but 0 or greater, then that says that at the stated MARR, minimum attractive rate of return, we have met that stated MARR if our present worth is greater than or equal to 0, and therefore we would be willing to go forward with this project. It would be a good idea. So remember, the MARR, you've read it in the textbook, stands for minimum attractive rate of return. I like to call it the hurdle rate. It's does this project pass this hurdle rate that it's returning 15% in this example or more. If the project returns 15% or more, then it's a project worth doing. And so when it returns 15%, the present worth is 0. When it returns more than 15%, the internal rate of return and the rate of return of the investment is greater than 15%, then the present worth will be greater than 0. So first thing you always want to do is draw a cash flow diagram. So we'll have that later when we get solving the problem. And in this case, you see we're trying to maximize profit. We have costs, so we have investment costs, land, equipment, working capital, building at the beginning. We have sales over 10 years. We have what we salvage value, what we can sell the building and the land for and equipment at the end of the 10-year study period that we're looking at. And then we have annual expenses. So it's we're gonna have to pay people to run and take care of the machines. We're gonna have materials in order to build the product, whatever this product is, et cetera, and that's given to us here. So we're gonna try to maximize the profit given the initial investment, the salvage values, and the revenue and, revenue and expenses that happen each year. So find present value given the annuity. 750 and 475 are annuities. We'll see that when we have that. And then we're going to find the present given the future value of the salvage value. So we'll see that in the cash flow diagram. And then I already mentioned do nothing is always a choice. Working capital is treated the same here in this problem as we treated in the project. So we have $100 of working capital we put in to get started, and then at the end, what does it say? At the end, we get all of the working capital back. And that's what's going to happen for the project too. You're going to put working capital in and the beginning and throughout the life of the project, and you're going to get it all back at the end. And internal rate of return, we'll do that at a later video. So we have 3 questions here. Solve for the present worth. That's the first thing we're going to do. And then we'll answer the question, what is the most the company would be willing to invest? So right now they're investing in land, building, equipment, and working capital. We'll see if that's the minimum they would be willing to invest or if they'd be willing to invest more. And then a second video will show the annual worth, and we'll talk about that when we get there. So let's look at the cash flow diagram. If this moves down, there we go. So we have the cash flow diagram. So here we have all of the initial investments listed, and you can see them there. We have the land, the building, the equipment, and the working capital. So we're showing this hopefully all to scale, and these are outflows. This is from the company's point of view, so these are all outflows. We have revenue coming in at $750,000 per year over the 10-year study period, and we have annual expenses going out at $475,000 per year over the life of the study period. And then we have the salvage value of equipment, building, and land at the end. This is basically what we're estimating the market value of these items will be at the end of period 10. So when we shut down, what we would be able to sell them for. And then we recover all of our working capital. Notice that 100K is the same. Okay, so that's our cash flow diagram. I'm going to move it up a little bit so we can look at things. So we're trying to find what is the present worth of all of these cash flows. We know that the interest rate is 15%. Our cash flows are at 15% per year. The cash flows are annual, and there's no mention of compounding within the year, so 15% is the time value of money that we're going to use. And as was stated in the problem, it's the minimum attractive rate of return. It's the hurdle rate, so we'll use that as our I. MARR is basically your I, your interest rate, to find the present worth of this project. So we set it up this very similarly to the way we have the other ones, only now we just have a lot more cash flows within the same project. So we have $1,250K going out in year 0. So if you add up the land, the building, all of those items, that should add up to $1,250. I'm showing it as a negative because that's a cash outflow. Then and that's already at the present, so I don't need to do anything with it. $1,250 times 0 is $1,250 times 0. Then I want to add the annuity, the $750K of annual revenue, and that is not at times 0, so I need to bring that back to times 0. So if we look at this right here where I'm circling, that looks, whoops, didn't mean to do that. That looks just like an annuity, right? So we take the $750K, we want to find the present given the annuity at the stated interest rate of 15% over 10 years. Notice again, there's no cash flow in times 0 for this annuity of $750,000 a year. Then we have a second annuity that is a cash flow out. So we have the $475,000 a year of annual expenses, but it's the same functional notation. Find the present given the annuity, 15% interest rate over 10 years. And then finally we have the items at the end of the period that are a single payment that we want to bring back to times 0. So we have working capital, salvage value of equipment, building, and land. That's all a single payment that we want to bring back to times 0. The sum of those is 900. Those are positive because someone is going to be paying us, so it's a cash flow into us. Functional notation is find the present given the future at the stated interest rate of 15% over 10 years because it's in 10th period. So again, we go to the our favorite compound tables at the back of the book. We find the page that has the compound factors when interest rate is 15%, and we know we're looking at the row where n equals 10 because we're trying to bring everything from 10 periods to times 0, and we search for these factors, find the present given the annuity, for the revenue and for the expenses, and find the present given the future for the single payment cash flow. So if you look at your book, you'll see that the functional notation, find the present given the annuity 15% over 10 years is 5.019, and it's the exact same time period, so it's the same for the expenses out as well. And then functional notation, find the present given the future 15% over 10 years is 0.2472. Now, can you use the formulas? Of course you can. You just plug 15% in for I, 10 in for N in the annuity formula, and this is the value that you'll get. Can you use the formula here? It would be 1 plus 15% raised to the negative 10, and you'll find that will give you 0.2472. So when I multiply those out, I get the string of numbers that you see here, and my final present worth is $352,000. My final present worth is positive. So we started off describing that when present worth is equal to 0 or positive at the stated interest rate at the minimum attractive rate of return, then we're going to move forward with the project. So in this case, we see we have a positive present worth of $352,000, meaning that all of these cash flows at 15% have an equivalent worth of $352,000 at times 0. That's positive, so that would say that does say that we have met and actually exceeded the hurdle rate. So we're not only making 15% on this money, but we're making more than 15% because we see we have a positive present worth. And so our decision would be to go ahead with the project. And that was question number 1. Question number 2 is how much would we be willing to pay to go forward with this project? So we see that we've paid $1,250 in investments to begin with across land, building, equipment, and working capital that you can't quite see here. So we would be willing to pay $352,000 more than that. We would be willing to go up to approximately $1,600 in initial investment because we would still have a present worth of 0 or slightly positive, and as long as our present worth is 0 or positive at the MARR, at the minimum attractive rate of return, in this case 15%, that says we've met the hurdle rate or exceeded it if it's positive, and so therefore we'd be willing to go forward. So the second question, what would the company be willing to invest? They'd be willing to invest $1,250 plus this $352 because that would still yield them a positive present worth. All right, if you have any questions, let me know.